All right, hello everyone. So this is Dr. Eric Insko from FGCU, and I wanted to make a quick video talking about antiderivatives. So far through the first 11 weeks in this course, we've spent the entire time just studying derivatives, which is really just half the story of calculus. And so remember that when we take a derivative, basically all we're doing is kind of simplifying the function by bringing the power down in front of the exponent, or bringing the exponent down in front of x, and then subtracting 1 from the exponent. So you guys should all be able to calculate these first few derivatives. If I ask you what's the derivative of x squared plus 3, we feed it to that green monster there, and we get 2x. And same thing for x squared plus 2. If I feed it to that green monster, he's going to bring the power out front, make that a 2x. And of course, the derivative of a constant is 0, so we don't see it when we're done taking the derivative. And then same thing for those two black functions, x to the 5th plus 3x and x to the 5th plus 3x minus 1. They both, you take the derivative of those things and you get 5x to the 4th plus 3. And, you know, in life and in math, it's nice to be able to undo something, right? You know, I think we've all been there where we've sent a text before we've looked at what autocorrect put in and been like, oh, I wish I could take that back, right? So that's kind of the idea of the antiderivative, is it's something that would undo the derivative. It'd be nice, you know, just for purposes of like being able to undo something, it's good to undo it. You know, that's usually what we have inverse functions for, right? So the question is, what is kind of the quote unquote inverse function of the derivative? Well, let's see. If I were to feed this 2x into the antiderivative, I'm not going to give it a name yet. I'm just going to say, let's feed 2x there. What do we get? Well, we should get x squared plus 3, or plus 2, or plus something, right? Like which constant should we pick here? Well, we really can't do that. So this isn't quite an inverse because we can't say exactly which constant we want, but we can say that it should be x squared plus some constant, okay? Because we can check. If we take the derivative of x squared plus c, we're gonna get 2x back, okay? So that's the best we can do. So we call this c, this big C, we call that the constant of integration. Okay, what about if I feed 5x to the 4th plus 3 into this antiderivative function? Well, it could be x to the 5th plus 3x. It could be x to the 5th plus 3x minus 1. It could be x to the 5th plus 3x plus any c. So I'm just going to write that like this, okay? X to the 5th plus 3x plus c. So as a general rule, if we're just taking a polynomial, I think that if we feed x to the n into this antiderivative function, let's just say, let's call him anti for now. He's going to spit out x to the n plus 1 divided by n plus 1, okay, plus c, right? So when we took derivatives, we brought the power down first, and then we subtracted 1 from the power. Now we're adding 1 to the power, and then we're dividing by it. That's how you undo the derivative. That's simple enough. Okay, and so we're calling this thing the antiderivative. So if you have a function f of x, the antiderivative is just the thing that when you take its derivative, it gives you f of x. So let's look at a few more examples here. So a couple more polynomials, or one more polynomial anyways. X to the 3rd plus x squared plus 7. You try it, pause the video, you try this one, and then I'll show you the answer in a second. Okay, well, this is going to be what? X to the, I'm going to add 1 to the power, so that's x to the 4th divided by 4. And x squared, well, I'm going to add 1 to 2, I get x cubed divided by 3. And then 7, you can think of that 7 as being 7x to the 0. So following that rule, that's 7x to the 1 divided by 1, which is just 7x, plus the constant of integration. And then it's a good idea to check that when you take the derivative again, you know, if I take d dx of that function, I'm going to get 4x cubed over 4. The 4's cancel. So I just get left with x cubed. And then I'll get 3x squared over 3. Perfect, the 3's cancel. And then 7x to the 0, that's just 7. And of course, the derivative of c is 0. So you get back exactly x cubed plus x squared plus 7. So that's the beauty of this, is that you can also check your work just by taking the derivative. Okay, so this next one we have x squared plus x to the minus 2. So this is some type of rational function, right? Or a polynomial plus a rational function. So what we're going to do here, well, we're going to just follow the same rule. We'll do x to the third divided by 3. And then this is going to be plus x to the, now minus 2 plus 1 is minus 1 divided by minus 1. And then I have to add the constant of integration. And of course, I could simplify that as x cubed over 3 minus 1 over x plus c. And you can take the derivative to check your work. Now this next one is kind of a tricky one, right? 1 over x is x to the minus 1. And if I try to follow this polynomial rule, it doesn't work, because look what happens. If I add 1 to the exponent, I get 0. So I'd get x to the 0 divided by 0. That would be undefined. So this is the one case where that power rule that we just did doesn't work. But you've probably seen this function enough times that you know exactly what the integral should be, right? What do I take the derivative of to get out 1 over x? Well, if you remember, it was a special function natural log of x. So I'm going to write that as natural log of the absolute value of x plus c, just because I haven't specified whether x is positive or negative, and we can only take natural log of a positive number. So we're just going to program into our minds, this is natural log of the absolute value of x plus c. We're only going to take positive values to feed in the natural log. Otherwise, you know, natural log just can't handle taking negative values in this domain. Okay, what about e to the x? You guys should all know the derivative of e to the x is e to the x. So the integral, or the antiderivative of e to the x, is e to the x plus c, okay? And just check your work that when I take the derivative of that, I'm going to get e to the x, and the derivative of c is 0, so that's back to where we wanted to be. Okay, and then the last one is cosine of x. And I don't know if you can see that. Okay, cosine of x. Well, when doing trig functions, especially just sines and cosines, I always liked putting this little wheel here of sine of x goes to cosine of x, goes to negative sine of x, goes to negative cosine of x. Okay, that's the derivative direction, that's d dx. And so to go the other way, for the integral direction, or the antiderivative, let's just call it anti for now. I'll define the notation in the next video for what the integral or antiderivative sign is. We go the opposite direction. So taking the derivatives like clockwork, and taking the antiderivative is, well, counterclockwise, counterclockwork, anti-clockwork. So, okay, cosine of x should go to sine of x plus c. And then if you take the derivative again, you end back up at cosine of x. Okay, so hopefully that was kind of enlightening. Thank you very much.